students, today we'll talk about significant figures. Already we have discussed about dimensions and errors. So two important things we are going to talk. One is significant figures and other is parallax. Now significant figures are very easy. When we measure a physical quantity, you should know the digit about the correctness of which we are sure, plus the last digit which is doubtful. So what is significant figure? The digits about the correctness of which we are sure, plus the last digit which is what? Doubtful. Okay, are called what? The significant figures. Significance of those numbers, significant what? Figures. So this is how we are going to significant, and it depends on the least, that least count of the instrument also. So that is how we are going to define about the significant quantity. Now there are some common rules we are going to discuss for the significant, some common rules. So we will discuss about that for significant figures. What are those common rules? So first of all is that when we follow them, first is that all non-zero digits are significant. So all non-zero digits are significant. That means I am giving an example also, that if x is 1, 2, 3, 4, then it has how many significant figures? Do you know? 4 significant figures. So it has 4 significant figures. Are you getting it? All non-zero. Even I am giving you an example of the another one, say x189. So it has 3 significant figures. Second is that all zeros occurring between two non-zero what? Digits are significant. So two non-zero digits are significant. So the zeros lying between them. So I am giving you another example, and for say that example is x is 1007. Now how many significant? Because they are between the two non-zeros, so 1, 2, 3, 4. So we have 4 for it, 4 significant figures. Got it for here? So this way we can, even I can give you another example, 1.0809. If I ask you how many, then it has 5 significant. 1, 2, 3, 4, 5 significant figures for this case. And then we are going to talk about the rule number 2, then 3. The third one is that in a number that is number less than 1, when we talk about the less than 1, so all zeros to the right of decimal point, all zeros to the right of decimal point, all zeros to the right of decimal point and to the left of a non-zero okay digit are not significant. So are not, remember, not significant. So I will give an example for this also. Say example is that x is say 0.0084. Now if I talk about that, how many? So only 2, 1 and 2, because the 0 on the right are not of significance. So I will say that it has two significant figures, okay, and or significant digits we can say. So significant digits. Now another example I can give you is that if I write x equal to say 1 point say 0084. I am writing now this. Now it has now how many? Can you tell me? Now it has 5. 1, 2, 3, 4, 5 because it will have 5 significant digits. Got it? Then rule number 4. All zeros on the right, all zeros on the right of the last non-zero digit, okay, in the decimal part, what are significant. So when you are going through this, you have to observe all these things. So example I am giving you that say x is equal to, and the example is that it is 0.00800. Okay. Now how many significant figures? After 8, 1, 2, 3. So we have 3 significant digits here, 3 significant figures or significant digits. We can say significant figures or significant digits. So this is how we are going to say. Another rule I am going to explain you. All zeros on the right, okay, all zeros on the right of the non-zero digit are not significant. So rule number 5, say if I say x is equal to what? 1000. Now it is 1000. So only one. It has one significant figure. Only one significant figure or one significant digit. So in the same way, if I say x is equal to 378,000, how many? Then it has 3. 1, 2, 3. So 3 significant figures in this case. So this is how we can say that we have 5. And then I can talk about the rule number 6 also. There is a 6 also, rule number 6, and that says that all zeros on the right, okay, all zeros on the right of the last non-zero, that is non-zero digit, becomes significant. So what it means significant? On the right of the last node becomes significant. That means if I am writing, suppose I am writing an example is that x is 3050 meter, a distance between 2 stations. Now certainly it has all 4. It has 4 significant figures. Remember, now even I can write it as 3.050 kilometer. Then also it has 4 significant figures. Even I can write it in this way, or even I want to write 3.050 into 10 to the power say 5 centimeter. Now certainly I can say that again it has what? The same thing, 4 significant figures. So this is another example which we can give. And then one is the rounding off. When we talk about the rounding off, so go through these all 6 things, and then rounding off we are going to talk. Rounding off is very important. That is the first one, is that if the digit to be dropped, is less than 5, okay, then you know that all of you know the preceding what digit is left unchanged. So that means very simple, that if I have x is equal to 7.82, it's an example, so it will be rounded out to what? 7.8. If I have x is equal to 3.94, it will be rounded off to what? 3.9. So this is rounded off. And then we can say that rule number 2, that means what 2 says, if the digit to be dropped is more than 5, if the digit is to be dropped, okay, and that is more than 5, then all of you know that what happens, preceding digit is raised by 1. So we know that preceding digit is raised by what? 1. Now I am going to give an example. Is that x is equal to 6.87? Then rule number 2. What is 2 for the rounding off? If the digit to be dropped is, I think all of you know, is more than 5. If it is more than 5, then the, you know that, then the preceding digit is raised by 1. So you raise it by what? 1. So I can give you an example for this. Is that, say example is that if x is 6.87, so rounding off you can write it as what? 6.9. If x is 12.78, what you can write? You know that rounding off 12.8. So you are rounding off these values. Okay. And then you even third, what it says, third rule, that if the digit to be dropped, if the digit to be dropped is what? 5 and followed by, say, digits other than non-zero, other than what? 0. That is the non-zero. Then the preceding digit is raised by 1. So you raise it by 1. How? I can give you another example. Say x is 16.351. Now 351. So we know that we are going to round it off. So what will it will become? What do you know? 16.4. And if I have x equal to 6.758, it is greater than that, then it becomes 6.8. So you are rounding off. So you should know the rules of rounding off when you do the calculation. And then rule number 4, what it says? It says that if digit to be dropped is 5 or 5 followed by what? Dropped by 5 or 5 followed by what? Zeros. Then preceding digit is left unchanged. Is left unchanged. But when? If it is even. So it is very important. So say example I am giving x equal to 3.250. So rounding off it becomes what? 3.2. Why? Because it is an even number. And then if x is 12.650, rounding off it becomes what? 12.6. So these are the basic rules for rounding off. You can see them. These are the examples given here. Now then, if there is any other, what will happen if it is odd? So then that means 5. If I say if digit, it's the same thing, to be dropped is 5 or 5 followed, you know that, followed by what? Zeros. Then the preceding digit is raised by 1. Now when it is raised by 1, can you tell me? Yes, if it is what? Odd. So I think you can understand it. Example I am giving, x is 3.750. So what it will be? Rounded off to 3.8. Or x is 16.150, rounded off to what? 16.2. So we are rounding it off. Why? Because 7 and 1 are the odd numbers, so rounded off to the higher one. So this is the significance of the significant figures, and then there is some rule for significant figures. Okay, significant figures, that is for their calculations. So significant figures in calculation. So when we talk about the calculation, we have two things here in our mind. One is related with the what? Addition, and one is related to the subtraction. So I am going to talk about one and one. So first is that in addition or subtraction. Okay, we are talking about addition and subtraction. The final result, when we talk about the final result should retain as many decimal places as are there in the number. These are very simple things. I will tell you, when you go through them with example, you will come to know what it means with the least decimal places. The least decimal places. Example I am giving is that 0.307 meter minus 0.304 meter. I think all of you know it becomes 0.003 meter. Or you can write 3 into 10 to the power minus 3 meter. So it remains same. Are you getting it? Multiplication and division is different, but here we see that it remains same, the significant digits. So it is an example for addition, or you can add also. So for multiplication division we have something different. So it is for addition and subtraction. Now we'll talk about the multiplication and what? Division. What happens in that case? That is, in multiplication or division, do you know the final result should retain as many what? Significant figures, as many significant figures as are there in the original number with the least significant figures. Now what it means, I will give you another example. I am giving example for that is significant figures. Now I am giving you an example. Say I want to measure a density. Now there is a mass given 4.237 gram and the volume is given in cubic centimeter 2.1. If I divide it, it comes 1.69. So what it shows that the significant digits, that at least it should be 3 significants. So in the above we see density to be repeated 3 significant figures least. So it is going to retain that. Okay. Are you getting it? In the same way, if I say speed of light is 3 into 10 to the power say 8 meter per second. We have 3 significant figures here. 3 significant figures here. And if I say 1 year is equal to 365.25 days. Okay. And it is written as 3.1557 into 10 to the power 7 second. So how many significant? 325. So 5 significant figures are in this. And then I talk about how to calculate light year, and 1 light year is, do you know, 9.47 into 10 to the power 15. So what we see here is that again there is 3 significant figure. So what is the thing is that the least significant figure should be there this is the speed of light, this is in 1 year, and this is in 1 light year. So 3 significant figures like this in 3 significant figures are the least to be represented. So in multiplication or division it is different rule. In addition and subtraction it is different rule. In addition and subtraction you have seen it is different. So these are the rules for what? Significant figures. So you can go through them, that how we are going to talk about the significant figures. Now I will talk about one very important method, and that is parallax method. Now parallax method, why I am talking about the parallax, you know that you measure the distances, and one of the measuring method is parallax method. So I am going to just explain this method. This is actually we get 1 or 2 numerical based on the parallax. So we are going to talk about the parallax also. Do you know what does mean a parallax? I will give you an example. You hold a pencil in front of you against some specific point. You do it on the background and look at the pencil by first your left eye and then by your right eye. So what do you see? You see a shift in the position of the pencil with respect to that background point. And this shift, this change is known as what? Parallax method. So parallax, that is known as parallax. What is parallax method? Is actually large distances such as the distance of a star or a planet can be measured from the earth, and it can't be done by direct meter scale. So from the earth, by which method? By a very important method, by parallax what method, remember. So it is a method used to measure the distance. And what I was saying is that there is a background point. Say this is the background point, and this was earlier A and this is B. So there is a shift. You can see it by taking left and right eye. So you find out there is a shift, like shift between 2 eyes, and this shift is known as, do you know, B. B stands for what? Basis. And this is the point, specific point. And you know this distance is say D, and you take it as B. So this is a parallax method, and this parallax method will be used to measure the distance for the, and this phenomena which you see by taking on right and left eye and change in the position is known as what? Parallax. And do you know there is an angle in between that, and that theta angle is known as parallax what? Angle. So we can see that this angle is known as parallax angle, and this can be used to measure. And how we are going to measure, I will tell you. See here. Say for example, we know that this is earth and these are the diametrically, and you want to measure any distance from these 2 diametrically opposite positions, say A and B. Do you know this will be what? This will be what? Basis. This will be D. This will be D. This is a star or a planet or any body. Okay, and this is theta angle. So if you know B, that is approximately the diameter, you can find out the D. And for a far distance in arc method, if you remember, if you have gone through, you know that this is R, this is L, this is theta, and how many of you know L is what? R theta. So can you find out the R? Yes, L by theta. Same method will be applied. Why? Because B by D, if you see, B by D is less than 1. D is very far. So almost AB's arc is taken as what? Arc is taken as what? Straight. It is taken as a straight line. So we take it as straight line. That is why very far distance it will be almost straight. So this method we are going to follow. For very easy we can find out it. Again here if I say what is B, you will say d theta. Then can you find out d? Yes, it is b by theta. So this way we can find out the distances through the parallax method. Here this b is acting in the same way. We can see like this also, that you can find out the different position, and it can be in this way also. Okay, so you can find out the way we can find out far distances through this method. And one thing I want to tell you, that what does it mean by the relations. If I ask you what is 1 degree, now 1 degree is, everyone knows, is what? Pi by 180. Yes or no? How? Because everyone know that 360 degrees 2 pi radian. So 1 degree is pi by 180 radian. You calculate it. So 1 degree comes, I will tell you, 1.745 into 10 to the power minus 2 radian. And in 1 degree, how many minutes I have? I have 60 minutes. So 60 minutes is 1.745 into 10 to the power minus 2 radian. So can I find 1 minute? Yes, I will divide it by 60. And when I divide it by 60, I get the value for that is near about 2.908 into 10 to the power minus 4 watt radian. And then how many of you know 1 minute is 60 seconds, and that is 2.908 into 10 to the power minus 4 radian. Can you find out 1 second? Yes, you divide it by again by 60. And then when you divide it by 60, you will get the value of 1 second. It is 4.85 into 10 to the power minus 6 radian. So what is the main thing is that you have to just know about the values. Again repeating, how much? 360 degree is 2 pi. And then 1 degree, you know that you just 2 by 360 is pi 180. 1 degree is this. Then in 1 degree, how many minutes? 60 minutes. Then 1 minute data you can get it dividing by. Then in how many seconds? 60 seconds. Then you get 1 second data as this. So we are going to use the parallax method to calculate the distance of our heavenly bodies like a star. But we can't find out the deep sky object distance by this method. So this is known as what? Parallax and parallax method. Okay, so thank you. Just go through it, and then in next we are going to discuss some numerical and questions based on parallax, significant figure, dimension and errors. Thank you, and watch all videos regularly.